Hi friends, welcome to the channel VLSI Digital Design Academics to Industry. Like and subscribe to motivate us to give best content by spending from own pockets. Today we are going to give a wonderful session on System Verilog and use of System Verilog while coding the flip-flops. You might be thinking that why I am teaching System Verilog in flip-flops topic. The point is that System Verilog is just a syntax, but I want to tell where to use this syntax and what are the best uses of this syntax. It is possible that you know the syntax, but where to use and how to use, what are the best possible uses of any syntax is the main topic, right? So today I will tell how to use this latest syntax given in the System Verilog. So let us assume that there is a protocol, any protocol called as protocol protocol A, PA. Okay, you can say protocol only, named as P. Okay, so protocol has 1, 2, 3, 4, 5, 5 signals, and it might be there are 120 signals. Big protocols, 120, 150 signals are there, right? Now, if you see, and width of each signal are different. X minus 1, X width, Y width, Z width, N width, M width. Protocol widths are also different. Now, the basic funda is that when we have a protocol controller, this is a protocol controller, and from the host side, if the protocol signals are coming, right? So first we sample it, right? And give to the next for the processing, like some processing, and then again sampling, then processing. That's how a design is made, right? Or there is or maximum times, or not maximum, like many times we have a handshake mechanism also. We have some handshake mechanism, FIFO kind of thing, or any other handshake mechanism where there is a ready handshake mechanism, right? And for example, I am sending this example, let us say these are the inputs to the controller, right? So this will be input to the FIFO, right? When we are writing to the FIFO, we are writing them A, B, C, D, E, right? Now let us assume that in protocol version 1.1, it was one there was 120 signals. In protocol version 1.2, it becomes 123 signals, and now width of the signal changed. X become X bar, Y become Y bar, Z become Z bar, N become N bar, and M become M bar, right? So these things changed. So normally what we used to do, so let us assume that this is 33rd number signal, 31st number signal, 30th number signal, 2th number signal, 2th number signal, right? So what we used to do, we used to simply write that protocol A delayed means put in the flop delayed by one cycle, right? Or introduce one latency, and we write protocol underscore A, right? So we have to declare this, and how many signal there are? 130 signal. So what we do, protocol underscore A underscore D underscore B underscore D C underscore D. So we will declare it how many times? 130 times if there are 130 signals, and then again putting the width of them, every width. And if let us assume that when I am declaring protocol A underscore D, instead of X I put Y, what will happen? Right, there is a bug, right? So avoid all of these kinds of bug, right? And I have to initialize also, I have to put them again, right, and right again and again and again, right? So to that the solution of this, we come with the solution of use of the struct, okay? Spelling is wrong, okay? So if you see, we can write the structs inside the struct. So let us assume this is a struct. We created typedef struct packet, right? And opcode, my opcode, and then the 4 5 signal inside it, right? Correct. We can write like this, and my opcode struct t. Now you can assume that this struct t contains all the inputs, right? Now, for example, in a protocol, there are 4 signals for data, four signals for control, right? 4 signals for DFT. So that's kind of internal structs also you can make. You can say instead of opcode, you can say data. In this side, my destination t side t dash, you can write control. Here you can write DFT. Now you have categorization also, right? And this data have 4 signals, DFT have 30 signals. Now you want to connect 30 with 30, you can connect it, right? You want to connect control with control, you can connect it, right? So that's how we can use it, right? So let us assume that. And last time what I told, we have to declare underscore A and underscore D underscore B underscore D underscore D underscore D, right? 130 times. So now when we are when we are staging them, for example, this is a staging, doing something, staging, doing something, staging, right? You say first flop, second flop, third flop. Now for this third flop, we have to declare again 130 data types. Here, some other name, 130 type, 130 data type. So see the RTL size, like 390 declaration itself, the file size is too high. Compilation will become very hard, large, right? So you can see where code is very small, the data type declaration is itself it is 390 lines, and we are connecting it. Then we use 390 lines again, initializing 390 lines, 390 lines again. So for three times, right, for three stage flop, we are using 390 into 3, right? In around 1200 lines, we are 1200 lines we are consuming. But if we will use this code, we can write this code in 5 to 6 lines. Once we have declared the struct properly, which will definitely take the 130 lines or 150 lines. Done. So what we did, we came down from 1200 lines to 150 lines of the code. So how beautiful code is, right? What I can do, cmd if flopped into this. So one single line is working for 130 lines. Same way here I have to initialize. I have singly seen 130 lines can be placed by one line, right? So 260 lines are saved in one flop and their declaration itself. Right? If there are three flops, we are saving 260 into including into 3, including the uh, initialization also, right? So one more thing, if tomorrow if a protocol is changed, right, so we have to correct in, so what we have to do, we have to correct, this is a flop, this is like some getting some flops, so we have to correct in this logic, we have to correct in this logic, we have to correct in this logic. So what we do, simply change the definition of struct, and this cmd if will be same. We don't need to do anything inside the flops. So your flop, your design will be configurable. When protocol change, I will only change the package file. You know where we write the struct, when I will teach the system Verilog, I will teach how this union structs are written, where these are written. So we have a file called package file, dot package, dot sh for this header files, right? So we have dot package files for RTL, right? We write only edit the protocol there in the package file, and complete RTL is itself changed. You see the beauty, and we just need 1 hour to do that. And from protocol one, like for example, we have PCI 3 down to 0, and we want to move to PCI 4.20. We just change the package file and we are done. Other than the logical change and the port level change, we can do in 1 minute. Just change the struct file, right? This is configurability, right? So I am just, and now I have giving a quiz to you, where to use union and where to use struct, and why many times struct is used, where many times union is used. I am not giving this answer. I want you people to get the answer. If you people will ask lot of questions about this union and struct, I will come with one more video depending upon the demands. So it's again a demand and supply game, right? You have to understand that this is industry, right? So please like and subscribe the channel to get more wonderful videos. One thing I want to say, I will come with very beautiful topics, right, which will help you not only crack the interviews, but also help you to design the very beautiful designs and get very quick promotions and good respect in your team. Thank you very much. Please like and subscribe the channel.